So we're about to begin our afternoon sessions. The first 25 minutes we'll be talking a little about the Pebble software, and then after that we'll prepare presentations by a number of attendees. So just quickly, how many people have got working hardware? Okay, reasonable number. Is anyone whose hardware is not working yet? Oh, Mark. Just one or two.
Might just give him mine.
Not finished yet.
Okay. Yeah. Well, we're here all week, and we'll make sure that everyone goes home with working hardware. This has been, I think, the biggest mini-conf we've had in terms of sheer amount of hardware and people, and it's gone, I think, smoother than it's ever gone. So it's awesome. We've normally not had time to cover software, so today's unusual. We're going to get to do that a bit, but it's going to be a bit like the hardware session. It's not possible to show you a set of slides, and from that you can just go and use an Arduino IDE and program it if you've never done this before. So what we'll do is we'll ask our helpers to help anyone install their IDE who has problems. Have a go yourself, but if you have problems, we'll get our helpers to do it. I'm not going to try and show you by slides, because it usually ends up being a problem like a USB drive or something weird. Okay, so the Pebble hardware and software. So it should have something that looks a bit like this. This one here is just running off battery. So if you go to Dick Smith, or actually not Dick Smith anymore, JCar or somewhere, because they still sell parts, you can just run it off battery, and it should fire up with a display and so on. So this is what we're aiming for. This one also has a Nintendo touchscreen, and you can get those online pretty cheaply from places like Deal Extreme and so on for about $3, or a little bit more from SparkFun. So this is the list of hardware that's on this device, and Luke, who has put a lot of effort into designing hardware for our hackerspace, has done a wonderful job with the help of Mark and John. And if we can always ask him later for more details about the hardware. But in short, this is what's here. And the Nintendo touch panel and the Zigbee mesh networking, which is this small chip up here, is optional. So a $25 part you can get from SparkFun. You need two, one for the Pebble and one for your computer if you want to do some mesh wireless networking. So. What I'll do is, this part's for people who aren't familiar with Arduinos. So the website is arduino.cc. That's where you go to download the IDE. There's great reference materials on there that tell you how the Arduino C language differs a little bit from normal C, just additional macros and functions and things, and also has lots of libraries. There's a playground of tons of examples and tutorials. It's a pretty rich resource. Another excellent resource is a local fellow, John Boxall, known as Tronic Stuff. He has a fantastic set of Arduino tutorials, so there's a wealth of stuff out there. So how many people have got their IDE downloaded and working? So quite a few. So anyone who hasn't? Yeah, okay. So about maybe 10 or so. So please grab a helper and to help you get that going before the end of the day. And also, there's a number of obviously in apartments where we'll probably do some birds of a feather sessions, something else like that, to help people throughout the week. So make sure you're up and programming. Right, so if you're familiar with C, you'll find that no trouble to program your Arduino. And even if you're not familiar with C, it's really just a matter of calling a few functions to write to the output pins, read from the input pins, and make some simple if decisions, a few for loops. So it's you can do some interesting things fairly easily. The Arduino provides additional macros to make it easy. So rather than having to deal with concepts almost like assembler, where you're sort of having to do ands and ors and read to change the pins, you can just call functions like digital read, digital write, analog read, analog write to talk to the pins, and just give the pin number you want to talk to. It might be pin 13 to flash the LED. Or it might be analog pin 0 to read the temperature sensor, and then you can just do a little bit of logic around whatever value you've written. And there's an absolute stack of libraries, so Google is your friend here. You can pretty much just Google Arduino and temperature, or Arduino and LCD, and you'll find a stack of examples. And the other nice thing about this is if you, once you've got this environment going, you'll be able to program your Leo stick. This device looks like an Arduino Uno. The Leo stick looks like something called the Arduino Leonardo, and people can help you change, just make the small mod to your environment so that you can program your Leo stick. So the hello world of the Arduino world is getting LED 13 to flash. So basically there's a sketch called Blink. In the Arduino world's programs called sketches. It's a bit weird. And daughter boards are called shields. I guess crazy Italians. And so what you do is you basically bring up the Arduino IDE, you go to the menu and say that you've got an Arduino Uno in this case. You then go to the menu and say serial port. So on Linux it's going to look like dev TDY USB 0 or something like that. And on a Mac it's definitely USB modem FD131. Then you just go to the examples, and there's an absolute stack of examples. There's dozens and dozens of them, and this Pebble we've built today is just a standard Arduino with a bunch of hardware already attached to it. And so with the exception of the LCD, which we did a little bit of a custom hardware thing there, because the LCDs take a lot of pins, about 6 or 7 pins, and we didn't have that many spare pins, so we basically use a shift register that only uses 3 pins. So for the LCD we did a bit of a our own custom library, but all the other hardware you can pretty much use directly. So once you've gone and loaded up Blink, you then just use file upload, and there's also a button on the IDE for, I think it's like a little right arrow these days, and then lights should flash, and then it's blinking, and that's pretty much the process for all Arduino sketches. So I'll run through that a little bit later. Okay, so software for the for this device. Turn off, it's getting a bit heavy. You can write small standalone programs for each piece of hardware on the Pebble. So you could just write something that just gets the temperature value and writes up to the serial port to your PC, or you could have a message come from your PC to change the to write something to the display. If you're a system admin, you might want to have the display somewhere convenient to tell you the status of your systems. So you can write these little standalone programs, and that's pretty simple. And what you'll see that the Arduino community does a lot of this, and they use delay loops, and so they might say, I want to read the temperature value every second, so I'll read the temperature value, delay for a second, read it again, and so on. And that's fine for simple things, but the Pebble's got quite a bit of hardware on there, probably about 6 or 7 things, and these all have different timing requirements. And by that I mean you might want to read the temperature sensor once a second, you may want to read the display 10 times a second. The little rotary encoder, that little knob that you can turn, that needs to be read about somewhere between 1,000 and 10,000 times a second. So if you're trying to interleave all this code and do delay loops, that's just not going to work for you. So certainly encourage everyone to start by writing simple little sketches to exercise your hardware, and we'll talk a bit about that later. But at some stage you'll need to do something that's a bit more event-driven, and there's quite a few libraries out there for doing this. The one I and a few other people developed over time is simply called ICO. And basically what it does is it divides your program up into a set of handlers, which are just simple C functions, a function for each sensor or actuator on your Pebble. And then it basically has an event loop that just simply calls these things. So you simply say, I want this handler to happen 10 times a second, or this one to happen 100 times a second. So it's a simple notion that just gets us away from delay loops that prevents code from being modular and workable. So the basic approach is to download the ICO library, I'll talk about it in a sec, download the Pebble application, test application, start the IDE, open the sketch and hit upload, just like you would for Blink. Okay. So to get the software for your Pebble, so stop your IDE. Hopefully everyone's got Git, but if not, you'll have to install Git. And then the Arduino stores all your sketches in a directory called it might be Sketchbook or it might be something else. But if you go to the Arduino Preferences tab, so just go to File Preferences, it will show you the location of your Sketchbook directory. And so the starting point for this is all your sketches that you write, your Blink and so on, they go into the Sketchbook directory, but you can also have a subdirectory called Libraries, and that's where you put additional libraries, like it might be something to drive the LCD, or it might be something to do the rotary encoder. And so into that we just basically use Git to clone the ICO library from that URL. So by simply getting ICO Arduino Git into that directory. That gives you the library. Then you can go back to the sketchbook and then clone the ICO pebble code. So after this, I'll put this a presentation online, and we'll update the arduino-conf.au. So apologies for not having done that a bit sooner. And I'll probably just mail that to LCA chat so you can grab that. So is everyone who wants these URLs, does everyone grab them now? Does anyone want another minute to grab these before we move on? Oh, if you want them back, I'll just come back to this slide and get them again later.
And
Yep.
it's worth mentioning that you don't actually need to install GitHub. You can download as a zip archive straight from GitHub.
Okay, cool.
So if you just go
github.com/git. All right. Yeah, what John's saying is GitHub provides all the code as a ready archive. This guy's got the idea. Just take a photo of your camera. I'll try and smile. So what John's saying is you just go to GitHub and just download a Targi zip or a zip, and you don't have to worry about Git. We'll do that. Show that a bit later. Okay, so once you've done the 2 Git clones or downloaded the archives and unzip them, you can just go to File Sketchbook, and you should see a new sketch there called ICO Pebble v2. And when you open that up, you'll see there's multiple tabs, not just one tab. And there'll be a tab for the main program, ICO Pebble v2, which has all the event handlers set up. There's a .h file. The .h file has all the pin numbers for the various pieces of hardware. So it says what pins the LCD is on, what pins the light sensor and temperature sensor are on. And then there's individual tabs for each device. So basically we've broken it into, so there's a tab for the LCD, a tab for the light sensor and so on. And what you can do is, if you don't want to dive into ICO straight away, what you can do is you can extract that code and just write your own simple sketches to exercise each piece of hardware. That's often a nice way to start. You can just look at the temperature tab and go, oh, there's the code for reading the temperature sensor, pull that into your own simple sketch and have a ball. And so once you've loaded this sketch, you can just hit upload. Right. So what I'll do is I'll pause there, and we'll do it. And I'll do it in the next session. Do a quick software walkthrough. Just checking the time. So it's 1:40 now. So I've got another 5 minutes. So I'll just quickly go through that for real, basically. So what have we got here? Got a browser somewhere. Not that one. Oh yeah. Okay. Right. So if you go to GitHub, you'll see at the top is ICO Pebble v2. That's the application, and then beneath that is ICO Arduino. So you can just click on ICO Arduino, and if anyone wants to say anything nasty about the presentation, now's the time to tweet, because it'll appear on the screen. So go for it. There we go. My bus. It's all right. It's not about us. Yeah, so go crazy, people. Right. So when you click on the Git repository, you'll see there's a Git read-only URL. So you can just cut and paste that. And as John was pointing out, you can also just click here to download the zip file if you don't. Okay, cool. And look, please don't all sit there quiet. Just if someone's got a better idea, just blurt it out. I'm cool with that. So that's the library, and then same deal for the ICO Pebble v2, and you can just grab that there. So I've already got this on my machine, obviously. Right, so where's the IDE? It's around here somewhere. Oh, actually, maybe it's not started. Code. Here we go. Right. Right. So there's the Arduino IDE, and I'll just connect the Pebble. So Freetronics kindly provided a USB cable in the kit, which is very handy. So once you've downloaded the library and the application, you should just be able to then go to File. Oh, sorry, that thing I'll quickly show you is if you go to Arduino Preferences, that tells you the location of that's the sketchbook location. So on my machine, it just happens to be in Documents Play Arduino. That's where I put it. So that's how you can find out where to unarchive the library in the application. And then when you go File, Sketchbook, you'll see. Actually, I think what I should do is before I get into this, I'll just show you Blink if no one's ever seen this before. If you go File, Examples, you go to Basics, and there's Blink, and that's the Blink code. It's Arduino code is fairly simple and fairly consistent. You have a setup function, and the setup function usually initializes the serial console if you want to use that, so the serial input-output, and then you also might set up any pins to say pin 13, which is the green LED, you say it's an output pin. And then there's a loop, so the setup function is called once, and the loop function is called indefinite, again and again forever after that. And we can see in the loop function it's basically writing to pin 13 saying set it high, delaying for a second, then it's setting it low, delaying for a second. So that's all it's required to say hello world in Arduino. So so getting back to ICO again, once you've loaded up, and you basically go File, Sketchbook, and there it is, ICO Pebble. Hopefully you won't have to wade through so many Arduino applications. And then you'll get all these tabs, and then it's simply a matter of just going either File, Upload, or just hitting this little round button here, which is a little bit more convenient. And this is what it looks like. Basically, actually I should take that off. Battery power, that's good. Is that when you hit the Upload button? I've got this right. I know I've done wrong. So I forgot to mention you've got to go board, select the board type, and then select the serial port. That's all good. So and down the bottom you've got a little console, and when we hit Upload, it should compile the sketch. And then okay, now it's stopped. You can see the lights blinking here to show USB activity, input and output, and then yeah, all sorts of madness going on. If you upload the Blink sketch, you'd have that little green LED here at Blink. So that's what I've got time for in the first session. So actually there's no break, just move pretty much on the next session. So does anyone have any questions so far? Mark?
Yes. So I was using ICO library, and I tried to use it last night with your IDE 1.0.
You may have used it before I checked in the version that works with 1.0.
Right.
So,
Sleep last night?
Yeah.
So,
yeah, I'm actually asleep now, just my eyes are open.
That's what you were doing. So Neil Paul had a version of yours that was fixed. The one you just released today basically takes over whatever he did. So it's the newest one that works everywhere.
No, what I did was I tagged the ICO library for Arduino version 22. So if you want to do pre 1.0 RDE, just go back to that tag, and everything now going forward will be for 1.0.
Oh, so it's not backwards.
Yeah.
So you want to keep both depending.
Yep, exactly. All right. If you've got sort of questions, at this point in time, if you've got questions of that complexity, we probably should take them offline or do them a bit later. Has anyone got some more basic questions that anything did make sense, or should I just keep going? Okay, I'll just keep going. All right. So what I'd like to do now is just a little bit of a brief code walkthrough to give everyone an idea of what code is used to interact with each sensor. So I'll just get past all the comments now. Is that visible from the back, or should I make the font larger? Okay, thought that might be the case. Right, so let's see. Would that be large enough? Yeah, maybe. I'll try 20, 28 maybe.
yeah, oh, excellent.
The code is twice as shiny now. All right, now the first thing I'd like to say is I haven't, this test code works and exercises every piece of hardware on the Pebble. there are some conflicts, and the main conflict is that the rotary encoder needs to be polled at least 1,000 times a second, if not more, for it to work properly when you're rotating the knob, so for it to pick up the changes in the pulses, so you can read the encoder. Unfortunately, the RGB LED fade handler, that's a bit of code that I sort of grabbed from Luke, and it wasn't designed to be in ICO. So what it does is it goes off and fades for like a second or more, and that's it gets in the way. So to have the knob work correctly, all you've got to do is just comment out the LED fading code. Just stop that event handler, and then the knob works. So at the moment, so what I'll do is over the next day or so is just slice that code up so it actually works nicely with the code.
I wrote some, I can give it to you.
Oh, okay, cool. Oh, job done. Yeah, so just the nice thing about Git is people can just fork your project, make it better, issue a pull request, and it's great. So yeah, let's do that. But
we have the URL to download this so we can look at it.
yeah, sure, I'll go back to that. Definitely. Ooh, that's ugly. Don't know what's happened there. Hang on, what do I want? I want Keynote. Okay. So the URL will be yeah. So the URL is going to be https github.com/geekscape, and then it's the top two projects. ICO Pebble v2 is the application, the test application, and ICO Arduino is the library. Is that sufficient to get you going?
Yeah.
Yeah. So is that the URL that you wanted?
Yeah.
Okay. Can I
Just for feedback, it's impossible to read one.
Oh, sorry. Okay, hang on a sec. Oh, yeah. Yeah,
It's a blurry projector.
You gotta click on the links to get there.
Yeah. Actually, is there anyone helping you who knows this URL can just walk over and type it in for anyone who needs it? I mean, there must be half a dozen people in the room who know. Yeah, you've got Paul or someone here. So if anyone wants to know the URL, just put your hand up and someone will come around and give it to you. I think that'll help. And someone asked for the slide. A slide? Which? So hang on. Which slide did you want? That one. Okay. Yeah. Yeah, we realise that the room's full of the spectrum of people who've never done this before to the people who know stacks more than me. So we're happy just to go, just answer questions on the fly and then get people to help you out.
That's 13. So that's the blink. Yeah.
So is anyone else who's stuck? Please just put your hand up and someone will come over. No, it's no hands. Yeah. And also, if this is not making sense now, some of us will be happy to be grabbed later and just sit down and do a one-on-one session with you and get you going. So, no, we won't be here all week because I guess there'll be other things happening. But we'll make sure.
Is this all going away today?
Sorry.
Is the entire thing going away today?
I assume so, but we won't be hard to find. So just come and grab me for a sample. I'm happy to sit down with people one-on-one and just work through stuff. It's not possible to cover everyone's questions in this sort of format. So it's a best effort type thing. But this is more than we've done in previous years. All right. What time have we got? 1:52. Right. All right. So I'll just go back to a bit of the code walkthrough. In the setup function, you can see a serial begin that just sets the baud rate to 38400 baud. And so one of the tricks is that when you bring up the serial monitor, So you can bring up a serial monitor. You need to make sure that the baud rate is 38400 baud. And one of the things you can see right now is that's connected this window to the USB input/output of the pebble, and you can see the pebble is giving the temperature, which is it claims is 28 degrees at the moment. And if I put my finger on the temperature sensor, yep, temperature sensor is going up.
My question is how accurate is this between us two? Is what degree different?
We'll have to grab the hardware guys. That's a hardware question. Duck that one. Look, I think the fact of the matter is, like half a degree difference is not surprising. I believe also the temperature is based off the analog reference, and so if you've got I think if you have a slightly different analog reference, that might make a difference as well, I suspect. But check with a hardware guy. The best thing to do in any situation is normally to calibrate it against a known good source and then go from there. Okay, right. So I'll just get rid of this. So after the serial port's been set up, you'll see there's this set of event handlers for the clock. So up on the top. So once you've got the software running, up in the top right-hand corner of the LCD is a little clock, and the clock handler function just looks after that. There's the LCD handler that looks after keeping the rest of the LCD updated. So the LCD displays the position of the rotary encoder, it displays the temperature, it displays the light sensor. So that the LCD handler looks after that. The light handler is just a simple function that just gets the current light sensor value. The RGB LED fader does the sort of the eye candy of the flashing RGB LED. The rotary encoder, you can see this is called every millisecond. So what it's doing is the rotary encoder has two pins, and as you rotate it, the pins basically go up and down in opposition, and basically by looking at the order in which the pins go up and down, you can tell whether you're rotating left or right in single increments. So that's what that does. The serial handler, that just looks for you typing on the serial monitor. So if I just bring the serial monitor up again, go away polycarbonate one. Who are you? Right, so bring up the serial monitor again. What you can do is, if I can hold it up, it's a bit hard. But if I type 1 into the window, a little red LED went on. That indicates that relay 1 went on. And if I type a 2 into that little window up the top and hit send, you'll see the other green LED's gone on. So you can basically, that's just demonstrating that input from the PC is controlling the pebble, and also that sensors on the pebble are being sent up to the PC. All right, so the serial handler is just looking after serial input. There's the temperature handler, which is just reading the temperature sensor every 1,000 milliseconds, and that's just writing that out to the serial console and the display. And lastly, there's the touch panel handler, and that's being called currently 4 times a second. And what that's doing is that's putting voltages across the Nintendo touch panel and just determining where your finger is, like a little potential divider, and giving those XY values. So that's everything that's in the main code. In the .h file, the include file, are all the pin numbers for the hardware. So there's a brief description of the hardware and the pins and what's on them. So we can see that pins 0 and 1 are the USB input/output. They're also the same pins used for the Zigbee mesh networking. Then pins 2 through 5 are for the LCD. So how that works is if you think of wanting, so you want to send a character, 8 bits to the LCD. What it does is it's sent at 1 bit at a time. So the pin LCD data is what the bit value is. And the clock and the strobe are then used to send that to clock that out 1 bit at a time to the latch, and then it basically strobes and says, right, you've now got 8 bits, and that's then sent to the LCD. So what that allows us to do is, rather than having to send out all the data in parallel and use a lot of Arduino pins, we can just send it out one bit at a time. Pin 5 is the LCD backlight. That uses what's called pulse width modulation to simulate an analog value between 0 and 255, and so you can change the brightness of your LCD. And what I've done is the test code. If you rotate the knob, that changes the LCD backlight value. Pins 6 through 7 are for the rotary encoder. Hang on a sec. So A is one of the inputs and B is the other input, and so those are the two inputs that it looks at in opposition to see whether they're rotating left or right. And the rotary push, if you push you can actually push, you may not have realised this, but you can push the encoder as well. So this, you can actually push this, and it changes the word on the display from lowercase to uppercase to show that you've pushed it. And so what you can do with so even if you haven't got a touch screen, you can use the rotary knob to, you can have like a little menu, so you can you rotate to go through the menu values and then push to select and then go in and change values. So there's enough, it's minimal, but there's enough input to actually do like a very simple system of going through a menu and changing values. And so you might like to have a temperature set point. So you might say, I want to have a set point of 25 degrees, so I use the rotary encoder to set that value, push that button, and whenever the temperature goes above 25 degrees, your PC gets a message. So you can just use your imagination to put the hardware together in different ways. And then there's the analog pins. So analog pin 0 is your temperature. Analog pin 1 is the light sensor. The light sensor just gives you a value between 0 and 255. 0 is dark, and 255 is so probably should wear sunglasses. And analog pins 2 through 5 are the touch panel. We're going for time. Another 10 minutes. The way the touch panel is really interesting. It's just a flat piece of glass with a membrane on the front which is resistive. And the way it works is you put 5 volts on the top and 0 volts on the bottom, and where your finger presses basically acts like what's called a potential divider. So you can, depending upon where your finger is on the screen, you can read off on the side. You can read off the voltage, and if it's at 5, it means if you read off 5, it means your finger's at the top. If you read off 0, it means your finger must be at the bottom. And then once you've read that, gives you the Y coordinate. Then what you do is you put 0 volts on the left-hand side, 5 volts on the right-hand side, and then you can read off the X value. And you just keep flipping and doing that many times a second. If you want to have really fine grain, you can obviously sample 10 or 20 times a second, or it's up to you. So it's kind of cute the way it works. The Nintendo touchscreen I've got is kind of that sort of aspect ratio, and the displays of that aspect ratio. So you could put it on front. So I've worked two ways. One is I've put it on front of an LCD so you can change the LCD. Seen? Like a trackpad. Yeah, like a trackpad. Now the other way you can do is actually just go and print out a piece of paper this big, or I'll actually just use a pencil and go on off a little slider and just put that behind the glass, and you've basically made the world's cheapest, nastiest user interface. But you then put another bit of paper and you've got a different user interface. It's kind of so. Anyway, so let's have a look at a really simple handler. So if we go back to the main code, you'll see there's a handler called the light handler, which is called every 1,000 milliseconds. If we go to the light handler, we'll see all it does is simply goes light value, analog read from the analog pin. So basically, calling that function will give you a value between 0 and 1023 because it's a 10-bit sample. And then the variable light value has just got this number which you can then do whatever you want with. You can send it up the serial port, you can put it on the display. It's pretty simple. So that's as simple as it gets. Another one that's fairly simple is the temperature sensor. Some temperature sensors are digital, so you talk to them with a digital protocol and you get back an answer. Things like the Dallas Semiconductor 1-wire sensor. The sensor on the Pebble 2 is very simple. It's just it just gives you an analog value depending upon what the temperature is, and you've just got to do a little bit of maths. So what Luke worked out was if you read the pin and divide by 4 and subtract 20 and a half, this sounds like sort of some magic sprinkles. That gives you the temperature value as a floating point number. And then you can once again do whatever you want with it. In this case, I break it into the whole portion, the fractional portion, and then put it on the display. One thing to note is, we normally don't think twice about doing floating point arithmetic. This is an 8-bit microprocessor, and it's got no floating hardware support. So if you do a float, it's basically going to suck in a floating point library and take much, much longer than if you were just doing simple integer arithmetic. So the thing, we're so used to these days having gigabytes of memory, gigahertz of processing power. You've basically got 16 megahertz, so it's executing, give or take, 16 million instructions a second. Not quite, but close enough. It's only got 8 bits wide data. So if you manipulate a byte, and multiply 2 bytes together, add 2 bytes together, that's so much faster than if you're using integers, because all of a sudden it's got to do many more operations. And if you start doing multiplies and divides, it's a lot worse. So it's really about being frugal. You've got 32K of flash, where your programs are stored, which actually it's a little bit less than that because the bootloader takes up some room, but about 30K. But you actually can do quite a lot in 30K. So I think all the Pebble code at the moment, talking to all the hardware, actually I'll find, if you look at the screen, it's actually around 8 or 9K at the moment? 9K at the moment, including the bootloaders. So you've got about 20K left to do stuff. But you've only got 2K of RAM, so that's used for your heap and your stack. So you've got to watch out for that. And one thing I've done at the up in the start of the program, see it says print free RAM there. That calls a little function that determines how much RAM you've got free. So it's handy to do that to make sure your stack and your heap haven't collided. So every time you do a function call, it uses a bit of stack. Every time you allocate a variable, it uses a bit of heap. Yeah, sorry.
So I saw some code that would print at compile time how much was used, how much of SRAM was used as a warning when you're going too high, your strings are too long or whatever. Was that ever integrated, or there's still nothing in the IDE that does that?
Not that I know of. I think it's still people doing third-party efforts as far as I'm aware.
Okay.
So
yeah, you have to do it by hand after the fact.
Yeah.
After you spend hours debugging what
Yeah, but basically you're working on the bare metal here. You pretty much the C code you write. There's no operating system. There's nothing between you, and there's no safety belts or airbags. It's if you use up memory or something like that, things just mysteriously stop or go weird on you, which is fun. Anyway, so how much time have we got? About enough.
2K, a small try 5 4 bytes, and then you really see weird stuff happen.
Yeah. I won't go into it now, but one trick you can do is if you start using lots of strings and lots of big messages, what you can do is rather than having those consume RAM, which is very valuable, you only got 2K, you can also, there's a macro you can use to put that into Flash, and so it's kind of efficient. So there's all these sort of tricks you can use. The other thing you've got is 512 bytes of EEPROM. EEPROM is a memory that is still is preserved when you power cycle the device. So if you turn the device off and turn it back on again, the EEPROM values are the same. So you can use that for, if you want to have a temperature set point, you could store that into EEPROM. There's a little function that does that for you. And then when you turn the device on again, you have to change the set point all the time. It's just there for you. So there's quite a lot in these little devices. They're very clever. Right, so let's see what else is useful. I'll go to pretty much one of the more complicated things, which is the LCD code. That's quite so up the top of the LCD code, I'll just make a bit more space. There's a little bit of ASCII art to show you how the microprocessor is connected to the shift register and then connected to the display. So people who are interested can look a little bit more about how that works. And so the code in this module is broken into 2 parts. There's a low-level code that does all the work, shoveling the bits around, and probably most people won't be interested in that. So that's at the top. But so things like LCD setup and LCD initialize. But if you go down further and further, you'll find there's methods like LCD position, LCD write number, and LCD string. And they're the sort of things you'll use to basically go LCD position, X coordinate, Y coordinate, LCD write string, LCD write number. And that allows you to take a temperature value and write it on the LCD at a certain position. But it's not a graphical display, so you've got to make sure that you clear the space after you. You've got to worry about refresh rates. Refreshing about 10 times a second is pretty good. It doesn't consume all the processor, and yet it doesn't appear to flicker too much. And so yeah, there's lots of it's challenging in a different way. Look, there's so much more I could talk about, but I'm probably running out of time. John or anyone, is there anything I should have covered that I haven't? Yeah. Yeah, look, it's very, very difficult to get, if you've never seen this before, to get you across all this. But we'll be around all week to help out. And you start with blinking a light, and then you basically then press the button, and the light blinks when you press the button. You just work up in baby steps, and so it's all good. And everything you learn here is directly applicable to the Leo stick. So if you know how to blink a light on the Pebble, you know how to basically blink the RGB LED here. And if you know how to blink it in red, You just replicate that 2 or 3 more times, you can then blink it in blue and green, then start, all the colours of the rainbow. The piezo library, the piezo hardware, in the Arduino library there's a thing called tone, and it's very tempting to use tone and start getting out the Close Encounters theme or whatever your favourite music is. Please don't do that because it breaks the USB library at the moment. This is a bleeding edge device, and so there's things like that. But what you can do though is if you toggle the output pin at the right rates, if you toggle it 440 times a second, you'll get an A. And if you toggle a bit faster, you can basically make your own music by just toggling the bits at the right rate. So that's how you play music on this thing.
Is it a PWM pin or is it just a standard digital?
It is a PWM pin, but there's limitations with the timer that's used in the library that will probably get fixed up in a future release.
Yeah. Pretty much every question you ask will be a simple answer, but the real answer will be more complex.
So when you say future release, that's future release of the IDE
Of the
and
IDE,
compiler?
Yeah.
The tone library is upsetting the timer that's being called for the USB servicing. So only if you call it on that, you can some other stuff.
Yeah.
Is that what we just heard? Yeah.
Ah, cool. All right. So I'd like to finish with a couple of things. Firstly, if you manage to get time and everything else, I'd like to put in place a little bit of infrastructure to help people use their Leo stick, because not everyone's going to want to dive down to the depths of the Arduino code. So if I get my head around that, I'll try and get something up in the next day or so that people can do some more interesting things. But basically get you... it's great to flash a light, but the novelty wears off. What's really cool is to be able to use its inputs, have that to go to your PC, and have that go out to the network, and then have people's Leo sticks talk to other people's Leo sticks, or those sort of things. All this stuff is possible, just a bit of imagination infrastructure, so we'll try and help people out with that if we can. The other thing I want to quickly say is 2 years ago, this is what the first version of Pebble looked like, and now you've got something that's much more refined, but it is a clear heritage, and hopefully over time we'll keep improving these things. So there might be Pebble V3 in a couple of years, or a better version of the other kit. So it's really interesting to see the capabilities of the community get better in terms of the manufacture of the hardware and the design. I just wish we're doing it all in the software, but we're getting there. What is the other thing I want to show? There's also people here who are playing with a thing called the USB Droid. It's an Arduino that basically allows you to connect your Android device to an Arduino on the hardware. And so guys like Philip Lindsay and John is doing a talk about basically being able to do a little Android application that basically press buttons and it changes inputs and outputs on your Arduino or sliders and things like that. So connecting your Android devices to your Arduino. And also starting to play with things like open source routers, where basically you can take an open source hardware router, and then that's another Arduino that Luke's designed that does current sensing. So that just basically hooks directly to the router. So when you see the Leo stick, you see this little what looks like a little limited device that hooks in the side of your PC. This is really just the start of doing an awful lot more. So hopefully we'll have inspired some people to get stuck in and do some very cool things. So I think that's about it. So I'd like to thank John and Mark and who've done it, and Luke for the design, who've done a superb job pulling us together, and also everyone who helped today from the hackerspace and from people have come from Adelaide and people have come from Perth. The Perth guys helped us out in the Maker Fair, so I'd just like to give these guys a round of applause for doing another great job. And thank everyone for making this. It's been an awesome day, so thank you.
Thanks, Andy.